Look up at the night sky on a clear winter evening, and you'll see one of the most dazzling sights in the cosmos, the Orion Nebula. A glowing cloud of gas and dust. It's not just another speck in the darkness. This is a cosmic cradle, a place where stars are born and where mysteries hide in plain sight. Even through a small telescope, it shimmers with an otherworldly glow, revealing colors and shapes that defy explanation. But what makes this nebula truly special isn't just its beauty, it's the sheer number of bizarre, almost impossible phenomena lurking within its depths. Nebulae are the universe's storytellers, vast clouds where the raw materials of creation swirl into new worlds, and among them, the Orion Nebula stands apart. Located just 1,300 light-years away, it's one of the closest and most active stellar nurseries we've ever observed. Here, newborn stars blaze to life, sculpting the gas around them into eerie pillars and ghostly tendrils. But that's just the beginning. Hidden in its glowing folds are objects that challenge our understanding of physics' mysterious voids, rogue planets drifting untethered, and even hints of structures that shouldn't exist. In this video, we're diving deep into 30 of the most astonishing secrets this nebula holds. From swirling vortexes of antimatter to stars that behave like cosmic rebels, each discovery peels back another layer of the universe's strangeness. Some of these phenomena are so puzzling, scientists still debate what they're seeing. Others hint at forces and laws we've yet to uncover. So buckle up, we're about to embark on a journey through one of space's most enigmatic wonders, where every twist and turn reveals something new, something unexpected, and something that will leave you in awe of the cosmos we call home. At the heart of the Orion Nebula lies a cosmic battleground, the Trapezium Cluster. This tight-knit family of stars is young, brash, and unbelievably powerful. The four brightest members, each just 1,000,000 years old, burn with a ferocity that dwarfs our own sun. Their radiation doesn't just illuminate the nebula, it rips through it like a storm, carving out vast cavities in the surrounding gas. Imagine standing too close to a hurricane while someone blasts you with a flamethrower. That's the kind of chaos these stars unleash daily, but their most striking impact isn't destruction, it's creation. The trapezium's stellar winds act like cosmic sculptors, compressing nearby gas into dense knots where new stars ignite. Some of these infant suns are smothered before they can even take their first breath, while others emerge as runaways ejected by gravitational tugs of war. The result, towers of gas that look like frozen tidal waves, their crests glowing under the relentless ultraviolet glare. These formations, known as protoplanetary disks, are cosmic nurseries where planets might one day form if they can survive the trapezium's brutal environment. What's truly baffling is how these young stars defy expectations. They're not just hot, they're volatile, spinning so fast they're nearly tearing themselves apart. Some whip around at over 200,000 miles per hour, flinging material into space like a spinning sprinkler, and their magnetic fields twisted into knots strong enough to snap metal like twine. This isn't just star formation, it's star formation cranked up to 11. Every discovery here forces astronomers to rethink how stars are born, live, and die. The Trapezium Cluster isn't just shaping the Orion Nebula, it's rewriting the rules of stellar adolescence. One of the most spine-tingling sights in the Orion Nebula isn't a burst of light, it's a shadow. Lurking within its glowing expanse is a structure astronomers call the Cosmic Bat, a colossal silhouette stretching 2 light-years across. This isn't just some trick of the light, it's the ghostly imprint of a protoplanetary disk, a swirling ring of dust and gas so dense it blocks the nebula's radiance behind it like a celestial eclipse. Picture a lantern shining behind a paper cutout, only here, the lantern is a newborn star, and the cutout is a cosmic construction site where planets are taking shape. But why a bat? The disk's uneven edges warp the shadow into wing-like curves, giving it an almost eerie, lifelike silhouette. What makes this shadow so valuable to scientists isn't its shape, though it's what the darkness reveals. By studying how light filters around its edges, researchers can map the disk's structure down to the smallest eddies and clumps. They've found it's not a smooth, flat sheet. It's warped, twisted, and rippling with turbulence, like a vinyl record left too close to a heat source. These imperfections are clues. Every bend and ripple hints at unseen planets tugging at the disk, their gravity sculpting the material like invisible hands kneading dough. Even more intriguing, the cosmic bat's shadow changes over time. Recent Hubble observations caught its wings flapping, subtle shifts that suggest the disk isn't just passively floating, it's dynamic, reacting to the violent environment around it. Radiation from nearby stars erodes its outer layers, while newborn planets within it carve gaps, their orbits sweeping clean paths like cosmic Zambonis. It's a snapshot of a solar system in the making, frozen in a shadow play. And here's the kicker: disks like this one are everywhere in the universe, but we rarely get to see their structure so clearly. The cosmic bat isn't just a curiosity, it's a masterclass in how chaos gives birth to worlds. Tucked between the glowing gas clouds of the Orion Nebula, there's a bizarre structure that looks more like a celestial picket fence than a cosmic formation. Scientists call it the Orion Bar, a razor-thin ridge of dust and gas where the conditions are so extreme. They've turned this region into one of the universe's most efficient chemistry labs. At first glance, it appears deceptively simple, just a dense wall of material backlit by blistering radiation. But peer closer, and you'll find a frenetic dance of atoms and molecules colliding and combining in ways that shouldn't be possible under normal circumstances. What makes the Orion Bar so special isn't just its shape, it's the sheer intensity of chemistry happening here. The bar acts like a cosmic pressure cooker where ultraviolet light from nearby stars slams into the gas, ripping electrons from atoms and sending shockwaves through the surrounding material. This energy doesn't just heat things up, it breaks molecules apart and then forces them back together in new, unexpected configurations. Think of it like a bakery where the chef not only bakes bread but also invents entirely new recipes mid-process. The result: complex organic molecules, including compounds like methanol, formaldehyde, and even water ingredients that are fundamental for life as we know it. But the real shocker: these reactions are happening in space where the environment is so harsh, scientists once thought such delicate chemistry couldn't survive. The Orion Bar defies that assumption, proving that the building blocks of life can form in the most hostile corners of the cosmos. Some of these molecules are clinging to dust grains, forming icy coatings that act as tiny chemical factories. Others are caught in a constant tug of war between destruction and rebirth, torn apart by radiation one moment and reassembled the next. What's truly mind-bending is how this process mirrors the early stages of our own solar system. The same types of molecules brewing in the Orion Bar may have once drifted through the cloud that gave birth to our sun and planets. That means this chemical chaos isn't just a curiosity. It's a glimpse into how the raw ingredients for life might have arrived on Earth billions of years ago. Every time astronomers study this region, they find something new: carbon chains, ring-shaped molecules, even hints of amino acids. The Orion Bar isn't just a wall of gas, it's a recipe book for the universe written in atoms and light. Amid the swirling chaos of the Orion Nebula, there's a structure so peculiar it looks like it was carved by an invisible hand, a vast, spinning propeller etched into the gas. Stretching nearly half a light-year across, this bizarre formation defies simple explanation. At first glance, it seems like the wake of some cosmic ship, a perfect spiral of material twisting through space. But this isn't the work of an interstellar engine, it's the signature of forces we're only beginning to understand. The leading theory suggests this propeller shape is a cosmic fingerprint left by a young star hiding just out of view. As the star spins, its powerful magnetic fields act like a giant mixer, churning the surrounding gas into this striking pattern. Imagine dragging a spoon through thick cream, except here, the spoon is a star's magnetic field, and the cream is a sea of ionized gas heated to thousands of degrees. What's wild is that we can't even see the star responsible. It's either shrouded in dust or positioned at just the right angle to remain invisible, leaving only its mark on the nebula like a sculptor working behind a curtain. But there's another, even stranger possibility. This propeller might be the result of a cosmic collision. Some astronomers speculate that a runaway star, ejected from a nearby cluster, plowed through this region at breakneck speed, its gravity ruffling the gas like a stone skipping across a pond. The aftermath, a perfect spiral frozen in time. If true, it would mean this delicate structure is actually a scar, a reminder of the violence lurking beneath the nebula's glittering surface. What makes this phenomenon so captivating isn't just its shape, it's the way it challenges our assumptions. Magnetic fields shouldn't be strong enough to sculpt gas on this scale. Stars shouldn't leave such crisp, symmetrical wakes, yet here it is, a cosmic contradiction spinning silently in the dark. Every observation raises new questions. How long will it last? What will it become? For now, the propeller remains one of Orion's most elegant mysteries, a fleeting masterpiece written in gas and starlight. Deep within the Orion Nebula, a newborn star throws a tantrum, launching twin jets of superheated gas at speeds topping 500,000 miles per hour. But what happens next isn't just violent, it's downright surreal. Instead of firing straight into space, these jets curve back on themselves like a cosmic boomerang, forming a shape so precise it looks sculpted. This isn't some optical illusion, it's the handiwork of forces so powerful they bend the laws of physics to their will. At the heart of this phenomenon lies a star still swaddled in its dusty cradle. As it greedily pulls in material from a surrounding disk, the infalling gas doesn't just vanish, some of it gets channeled outward through the star's poles, ejected like water from a fire hose. Normally, these jets would shoot off into the void in straight lines, but Orion's boomerang jet has a twist, literally. The star's magnetic field, tangled and torqued by its rapid rotation, acts like an invisible slingshot, warping the jets into those eerie curves. Picture trying to spray a garden hose while someone yanks it sideways, except here, the hose is made of plasma and the force twisting it could crush a planet. What fascinates scientists isn't just the jet's shape, but what it reveals about stellar infancy. Most baby stars flicker between outbursts, their jets wobbling or sputtering as they find their footing. This one, its consistency incarnate, maintaining its boomerang arc for years without faltering. That stability suggests something extraordinary, a magnetic field locked in perfect sync with the star's spin, a rare equilibrium in an otherwise chaotic process. Then there's the composition. These jets aren't just hot air, they're laced with heavy elements like iron and silicon, atoms forged in ancient stellar explosions and now being recycled into new worlds. Every particle racing through that curved jet could one day end up in an asteroid, a planet, or even an ocean. It's a reminder that the universe doesn't just create, it repurposes, sending the building blocks of existence on endless journeys through space and time. Perhaps most tantalizing is how this phenomenon mirrors larger cosmic structures. From the arched plasma loops of our own sun to the twisted relativistic jets of black holes, magnetic sculpting seems to be a universal language. The boomerang jet is just the latest verse in that celestial poem, a fleeting, fiery stanza written in the heart of Orion. Amid the turbulent gas of the Orion Nebula, something eerily lifelike emerges, long, slender tendrils stretching outward like celestial fingers reaching into the void. These aren't just random wisps of gas, they're a direct result of some of the most violent energy in the universe, a process astronomers call stellar feedback. When massive stars, those behemoths dozens of times heavier than our sun, ignite, they don't just shine quietly. They unleash torrents of radiation and supersonic winds, carving the surrounding nebula into shapes that seem almost intentional. Picture a candle flame flickering in a breeze, except here the flame is a star and the breeze is its own ferocious energy. As these stellar powerhouses blast their surroundings, the gas doesn't just scatter, it gets sculpted. Denser pockets resist erosion longer, forming elongated pillars that point directly away from the star, like shadows stretching at sunset. The result: those haunting fingers, each one a monument to the push and pull between creation and destruction. What's astonishing is the scale. Some of these structures stretch several light years long, their tips glowing with the energy of the very stars that are dissolving them. At their cores, newborn stars may be forming, shielded by the surrounding gas even as their massive siblings blast it away. It's a cosmic balancing act: too much radiation, and the gas disperses entirely; too little, and new stars can't ignite. The fingers are the sweet spot where the universe's brutality and creativity collide. But here's the twist: these formations aren't static. Hubble images taken years apart reveal the fingers are in motion, their shapes shifting as the stellar winds buffet them. Some are dissolving while others grow more defined, like sandbars reshaped by tides. It's a real-time demonstration of how stars don't just inhabit their environments, they dominate them, molding entire nebulae to their will. And the implications go far beyond Orion. Similar structures appear in nebulae across the cosmos, suggesting this is a universal language of star formation. Every finger is a fossilized snapshot of energy in motion, a reminder that even in the vacuum of space, nothing stays untouched for long. The universe, it seems, prefers its art in motion, etched not in stone but in fire and shadow. One of the most recognizable shapes in the night sky isn't a constellation or a planet, it's a shadow. The Horsehead Nebula looms like a cosmic specter against the glowing backdrop of Orion's gas clouds, its silhouette so distinct it looks almost carved. This isn't just a chance alignment of dust, it's a towering structure 3 light-years tall, where cold, dense gas and dust block the light from the energetic star Sigma Orionis just behind it. The result, a celestial inkblot that's captivated astronomers and stargazers for over a century. What makes the Horsehead so mesmerizing isn't just its shape, it's the delicate interplay of forces holding it together. The nebula's neck and mane are under constant assault from the star's intense radiation, which should have torn this formation apart eons ago, yet somehow it persists. The secret lies in the magnetic fields threading through the dust, acting like invisible scaffolding to stabilize the structure against the chaos around it. It's a cosmic balancing act: gravity pulling material inward, radiation blasting it outward, and magnetic tension keeping it all from collapsing or dispersing. Peer closer and the Horsehead reveals even stranger details. The horse's nose glows faintly in radio waves, a sign of molecules like carbon monoxide being excited by the very radiation that threatens to destroy it. Meanwhile, the base of the nebula is evaporating, its particles streaming away in a faint, shimmering veil. This process, called photodissociation, is slowly eroding the structure, meaning we're witnessing the Horsehead in its final act. In another few million years, the stellar winds will erase it entirely, but the real magic lies in what this silhouette teaches us about star birth. The Horsehead isn't just a pretty shadow, it's a stellar nursery in disguise. Deep within its dark folds, pockets of gas are collapsing under their own weight, igniting new stars. Some of these infant suns are already flickering to life, their warmth creating tiny bulges in the nebula's silhouette. It's a reminder that even in the darkest corners of space, creation and destruction are inseparable partners. The Horsehead's fame isn't just due to its shape, it's a masterclass in how light and darkness interact across the cosmos. From the smoky tendrils of distant galaxies to the jet-black bands crossing Saturn's rings, silhouettes like this one are universal. They remind us that sometimes the most revealing views don't come from what's illuminated, but from what stands defiantly in the way of the light. Some of the most violent events in the Orion Nebula don't come from stars, they come from something far stranger. Hidden in its glowing depths are high-speed projectiles dubbed the Orion bullets, massive blobs of gas hurtling through space at over 200,000 miles per hour. These aren't gentle wisps of cosmic material, they're supersonic cannonballs, each one large enough to swallow our solar system whole, and the trails they leave behind. Fiery wakes that glow with the intensity of a blast furnace, etching scars across the nebula that linger for centuries. What makes these bullets so baffling is their origin. Unlike the predictable jets from young stars, these projectiles seem to erupt from nowhere with no obvious source. One leading theory points to an invisible powerhouse, a massive, deeply embedded star whose explosive outbursts fling these gas clumps outward like debris from a celestial grenade. The force required is staggering. Imagine a single event so violent, it could launch a chunk of gas weighing twice the mass of Pluto at speeds that would cross the distance from Earth to the Moon in under an hour. The bullets' behavior only deepens the mystery. Instead of slowing down as they plow through the nebula's dense gas, they accelerate, their shock waves heating the surrounding material to thousands of degrees. This creates those eerie glowing trails, each one a fluorescent fingerprint of the bullet's path. Some trails twist like corkscrews, suggesting the projectiles are spinning wildly as they tear through space. Others fork unexpectedly, as if the bullets shattered mid-flight like shrapnel. But here's the real kicker: these events might not be as rare as we think. Similar structures have been spotted in other star-forming regions, hinting that this could be a universal stage in stellar evolution. The Orion bullets are giving astronomers front-row seats to a process that might shape how nebulae evolve, dispersing gas and triggering new waves of star formation in their wake. Every impact stirs the cosmic pot, mixing elements and carving cavities where future stars could rise. What's truly humbling is the scale of time and space we're witnessing. Some of these bullets were launched centuries before humans first recorded the Orion Nebula in telescopes, their journeys still unfolding as we watch. They remind us that the universe isn't just a static painting, it's a kinetic masterpiece where even the quietest corners crackle with barely contained energy. The Orion bullets aren't just cosmic oddities, they're proof that creation and destruction often wear the same fiery face. Amid the swirling chaos of the Orion Nebula, a young star named LL Orionis is writing its name across the cosmos, not in light but in motion. The star's fierce stellar winds, racing outward at nearly 500,000 miles per hour, slam into the nebula's slower-moving gases like a spaceship plowing through celestial fog. The collision doesn't just create turbulence, it sculpts a bow shock so precise it could pass for a cosmic work of art. Picture the V-shaped ripple at the prow of a speedboat, but scaled up to interstellar proportions, with the water made of superheated plasma, and the boat a star barely old enough to fuse hydrogen. This bow shock stretches over half a light-year wide, its curved wings glowing with the energy of the collision. What makes it extraordinary isn't just its size, it's the physics unfolding at its edge. As LL Orionis wind rams into the nebula, it compresses and heats the gas to millions of degrees, forcing it to fluoresce in vivid blues and ultraviolet. The shock front acts like a cosmic pressure cooker, forging heavy elements and complex molecules in its wake. But the real marvel is its stability. Unlike the chaotic jets and explosions elsewhere in Orion, this bow shock holds its shape with near-perfect symmetry, a testament to the delicate balance between the star's unrelenting output and the nebula's resistance. Astronomers study this structure like a roadmap to stellar adolescence. LL Orionis is a T-Tauri star, a fiery toddler in stellar terms, and its bow shock reveals how such young stars interact with their nurseries. The shock's curvature even hints at secrets invisible to telescopes. By measuring its angle, scientists can calculate the density and speed of the nebula's hidden gases, like deducing wind direction from a flag's ripple. Yet the bow shock isn't static. Hubble images taken years apart show it slowly changing, its wings flexing as the star's wind ebbs and flows. Sometimes faint ripples appear downstream like echoes of the star's growing pains. These subtle shifts suggest LL Orionis isn't just a passive participant, it's actively reshaping its corner of the nebula, clearing space for its future planetary system. What's truly humbling is realizing this isn't unique. Bow shocks pepper the universe, from the tiny arcs around newborn stars to the colossal versions framing runaway stars hurtling through galaxies. LL Orionis version is simply close enough for us to see the details, a masterclass in how even the smallest stars can leave the grandest marks. One of the most breathtaking structures in the Orion Nebula isn't just standing still, it's practically singing. The so-called vibrating pillars rise like ancient skyscrapers of gas and dust, their silhouettes etched against the nebula's glow. But these aren't static monuments. Recent observations reveal they're trembling, swaying in response to violent stellar explosions nearby. It's as if the universe itself is plucking the strings of a cosmic harp, sending resonant waves through these colossal formations. The secret lies in their precarious position. These pillars sit close to a group of massive stars whose deaths are anything but quiet. When one of these giants erupts in a supernova, the blast sends shockwaves racing outward at millions of miles per hour. By the time these waves reach the pillars, they've slowed just enough to create a bizarre effect. Instead of obliterating the delicate towers, they make them oscillate. Imagine flicking a glass of water and watching the surface ripple, except here, the glass is light years tall, and the flick packs enough energy to vaporize planets. What's astonishing is how the pillars endure. Each vibration should, in theory, shake them apart, yet they persist, their bases anchored by magnetic fields tangled deep within the gas. These invisible lines of force act like cosmic shock absorbers, preventing the structures from unraveling entirely. Even more intriguing, the vibrations aren't random. Some pillars sway in sync, as if connected by an unseen thread, while others pulse at distinct frequencies, revealing hidden densities and substructures within their dusty folds. This phenomenon is rewriting the textbook on how long such formations can survive. Astronomers once assumed the pillars were ephemeral, dissolving within a few 100,000 years. Now it's clear their lifespan hinges on a delicate dance too close to a supernova, and they're annihilated too far, and they never feel the resonant vibrations that paradoxically reinforce their shapes. The Orion Nebula's pillars are caught in this cosmic sweet spot, where destruction and preservation strike an unlikely balance. Perhaps the most poetic detail is what these vibrations leave behind. As the pillars sway, they shed material in rhythmic waves, seeding the surrounding space with fresh star-forming fuel. Every tremor is a creative act, scattering the raw ingredients for new solar systems. It's a reminder that even in the vacuum of space, nothing is ever truly silent, and sometimes the universe's most enduring structures are the ones that never stop moving. In the heart of the Orion Nebula, there's a patch of sky that looks like it's on fire, a swirling crimson inferno nicknamed the Flaming Star. But here's the twist, those aren't actual flames. What we're seeing is one of the cosmos' most stunning optical illusions, a celestial magic trick where dust and starlight conspire to create the appearance of a blaze that could swallow planets whole. The secret lies in reflection. A bright young star, hidden just out of frame, bombards nearby dust clouds with intense ultraviolet light. Instead of absorbing the radiation, these dust grains act like microscopic mirrors, scattering the starlight in all directions. The red glow comes from the same physics that paints our sunsets. Shorter blue wavelengths get absorbed, while longer red ones bounce back to our eyes. But scale this up to interstellar proportions, and the result isn't just a rosy tint, it's a full-blown conflagration of light, with tendrils that seem to flicker and dance across the void. What makes this illusion so convincing is the dust's intricate structure. Unlike a smooth cloud, these particles are clumped into fractal-like formations, with ridges and valleys that cast shadows and amplify the fiery effect. Some filaments appear to twist like smoke, while others stretch into sharp, jagged edges, all sculpted by the invisible push and pull of magnetic fields and stellar winds. It's a cosmic trompe-l'oeil where three-dimensional chaos looks eerily like a two-dimensional wildfire from our vantage point, even more fascinating. The flaming star's intensity isn't constant. Over years of observation, astronomers have noticed subtle shifts in its brightness as dense dust pockets drift in front of the star, dimming or magnifying its reflected light like a celestial dimmer switch. Occasionally, new flames seem to ignite as stellar winds expose fresh dust layers, rearranging the illusion in real time. This phenomenon isn't just a pretty mirage, it's a masterclass in how light interacts with matter on galactic scales. From the ruby hues of distant nebulae to the golden halos around newborn stars, reflection shapes our view of the universe as much as emission or absorption. The flaming star reminds us that sometimes the cosmos' greatest spectacles aren't what they seem. They're invitations to look closer, question deeper, and marvel at the ingenuity of nature's illusions. Gaze at the northeastern edge of the Orion Nebula, and you might do a double take there. Etched against the glowing gas is what appears to be a spectral figure mid-stride, its elongated limbs frozen in perpetual motion. This is the Running Man Nebula, a haunting silhouette that plays tricks on the human mind while revealing profound truths about interstellar chemistry. Our brains are wired to seek familiar shapes, a phenomenon called pareidolia, but the science behind this cosmic mirage is anything but illusory. What we perceive as a sprinting figure is actually a towering wall of cold molecular hydrogen, backlit by the fierce ultraviolet glare of newborn stars. The body and limbs of the Running Man are dense pillars of gas so thick they absorb nearly all light trying to pass through, while the head and shoulders glow faintly from energized hydrogen atoms. This contrast creates the uncanny impression of motion, like a shadow puppet against a fiery curtain. But the real magic happens at the edges, where the stellar radiation carves intricate tendrils and ripples into the cloud, giving the illusion of flowing robes or trailing smoke. The Running Man isn't just a pretty optical illusion, it's a laboratory for understanding how light sculpts the cosmos. The same ultraviolet rays that make the hydrogen glow are also eroding the structure, atom by atom. Spectroscopic studies reveal the gas is being ionized at an astonishing rate, with particles torn apart and reassembled in a relentless cycle. Some areas fluoresce bright red as hydrogen electrons recombine with protons, while others emit eerie blue hues where carbon-rich dust reflects starlight. It's a dynamic canvas where physics and chemistry collide. What's truly remarkable is how fleeting this spectacle is. Unlike the slow geological processes on Earth, the Running Man's shape changes perceptibly over mere millennia, a blink in cosmic time. Already, the legs appear more fragmented than in early telescopic observations, and the arms are dissipating into wispy filaments. In another few 100,000 years, the figure will be gone entirely, its materials recycled into new stars or blown across the galaxy by stellar winds. This transient masterpiece offers more than just a lesson in stellar erosion. By studying its structure, astronomers have uncovered pockets of organic molecules, including precursors to amino acids clinging to dust grains within the dark folds. The Running Man isn't just running, it's carrying the building blocks of life through the cosmos, a reminder that even the most fleeting phenomena can have enduring consequences. Deep within Orion's chaotic core, astronomers stumbled upon a cosmic crime scene. A violent eruption dubbed the BNKL outburst. This wasn't some gentle stellar flare, it was the equivalent of a supernova's rebellious younger sibling, detonating with enough force to fling massive clumps of gas across interstellar space. The aftermath, a debris field stretching 2 light-years wide, littered with shrapnel like knots of molecular hydrogen still reeling from the blast, What makes this explosion so baffling isn't just its scale, it's the mystery of what triggered it. The leading suspect, a high-speed collision between two young stars, each still swaddled in their dusty cocoons. Picture two icebergs smashing together in a foggy ocean, except here, the icebergs are protostars packing enough mass to dwarf our sun, and the ocean is a seething cloud of gas heated to thousands of degrees. The impact would have been catastrophic, a gravitational pileup so intense, it released as much energy as our sun will radiate in 10,000 years. In mere seconds, but there's another twist. Infrared observations reveal the explosion wasn't symmetrical. Instead of a clean, spherical blast, it's as if someone aimed a cosmic fire hose in multiple directions simultaneously. This bizarre pattern suggests something even stranger. A runaway protostar, ejected from its birthplace like a bullet, might have plowed through the dense core at hundreds of miles per second. As it tore through the gas, its gravitational wake could have triggered shock waves that ignited the surrounding material like a chain reaction of stellar dynamite. The evidence hides in the debris. Some gas clumps are racing outward at speeds exceeding 90,000 miles per hour, fast enough to cross the continental United States in under a minute. Others trace graceful arcs, implying they were flung by a spinning object, perhaps a mangled survivor of the collision still reeling from the encounter. Radio telescopes have even detected the chemical smoke of the explosion, complex organic molecules forged in the blast's extreme heat, now drifting through space like cosmic fallout. What's truly humbling is how recently this happened. While recent in cosmic terms means 500 to 1,000 years ago, it's fresh enough that the debris hasn't fully dispersed. We're witnessing the aftermath while the nebula's memory of the event is still etched in glowing gas and twisted magnetic fields. It's a reminder that even stellar nurseries have their growing pains, violent, spectacular, and utterly unpredictable. The BNKL outburst isn't just a footnote in Orion's history. It's a front-row seat to the chaos that shapes the universe's most brilliant creations. Among the most dazzling displays in the Orion Nebula, few sights rival the celestial fireworks of Herbig-Haro objects HH1 and HH2. These aren't static clouds or gentle glows, they're supersonic jets of ionized gas, blasted into space by newborn stars with the force of a cosmic cannon. Each jet stretches light years across the nebula, its tip glowing like a match struck against the darkness, leaving behind a trail so vibrant it's visible across interstellar distances. The drama begins deep within a stellar nursery where a protostar no older than 10,000 years, a mere infant in cosmic terms, starts devouring gas from its surrounding disk. But not all that material falls inward. Some gets funneled along the star's magnetic field lines and shot out from its poles at speeds approaching 300,000 miles per hour. When these jets collide with slower-moving nebula gas, the impact is nothing short of spectacular. Atoms get stripped of their electrons, heated to tens of thousands of degrees, and forced to glow with an otherworldly radiance. The result, a cascading series of shock fronts that resemble fireworks frozen mid-explosion, crimson and sapphire tendrils curling through space like celestial calligraphy. What makes HH1 and HH2 so exceptional is their clarity. Unlike similar objects obscured by dust, these jets shine almost unobstructed, giving astronomers an unprecedented view of their structure. High-resolution images reveal intricate knots within the flows, each one marking a past outburst from the young star. It's like reading tree rings, but instead of years, these knots record moments of stellar temper tantrums, sudden releases of energy that sent fresh pulses of material screaming into the void. Some knots even show subtle bends, betraying the presence of unseen companions whose gravity tugs the jets off course like invisible puppeteers. The real magic lies in the chemistry. Spectroscopy uncovers a rich cocktail of elements within these jets: hydrogen, oxygen, sulfur, even traces of iron, all ionized and excited to emit light at specific wavelengths. The blue regions, that's energized molecular hydrogen. The red tips, oxygen atoms fluorescing as they slow down and recombine with electrons. Every hue tells a story of velocity, density, and temperature, painting a portrait of physics in its most extreme form. But here's the twist: these fireworks aren't permanent. The jets dissipate within a few thousand years, their material either dispersing into the nebula or collapsing back into new star-forming regions. HH1 and HH2 are fleeting masterpieces, reminders that even in the vastness of space, beauty often lies in the temporary, a brilliant flash in the cosmic dark, written in light and motion. Slice through the heart of the Orion Nebula with an infrared telescope, and you'll stumble upon something unsettlingly long, jagged corridors of darkness where the nebula's glow abruptly cuts off. These aren't mere gaps in the gas, they're structured voids so dense they swallow starlight whole. Astronomers call them dark lanes, and their origins are one of Orion's most persistent puzzles. Imagine dragging a knife through a fog bank and watching the mist refuse to close behind it. That's the level of defiance these structures exhibit against the nebula's luminous chaos. The leading theory suggests these shadowy highways are cosmic cul-de-sacs, packed with cold molecular hydrogen and dust so thick, even the Trapezium Cluster's blistering radiation can't penetrate them. But here's where it gets fascinating. Some of these lanes aren't just passive barriers, they're moving. Subtle shifts in their edges over decades hint at invisible masses warping their surroundings, like submarines cruising beneath an ocean surface. The prime suspects, rogue planets ejected from their birth systems and now drifting alone, or brown dwarfs, failed stars too puny to ignite nuclear fusion but hefty enough to bend spacetime around them. Infrared observations add fuel to the mystery. Certain dark lanes emit faint thermal signatures, suggesting hidden heat sources buried within. One particularly ominous structure, nicknamed the Serpent Spine, flickers erratically in mid-infrared wavelengths, behavior that aligns uncomfortably well with theoretical models of a young brown dwarf shrouded in a swirling storm of silicate dust. If confirmed, it would mean we're looking at a celestial phantom, an object massive enough to sculpt its environment, yet invisible to optical telescopes. Then there's the eerie geometry. Unlike random dust clouds, many dark lanes exhibit unnervingly straight edges, as if sheared by some colossal force. Magnetic fields could explain part of it, lines of force channeling dust into filamentary walls, but there's mounting evidence for something more dynamic. Radio telescopes have detected supersonic turbulence within these lanes, with gas motions implying violent past encounters. Some researchers speculate these could be fossilized shock fronts from ancient supernova, their pressure waves compressing the nebula's dust into these stark, knife-like formations. The implications ripple far beyond Orion. If dark lanes truly harbor free-floating planets or brown dwarfs in significant numbers, it would revolutionize our understanding of stellar formation. Current models struggle to explain how so many objects could be ejected from their birth systems so early in their lives. Each shadowy corridor might be a cosmic orphanage, brimming with worlds untethered from any sun, places where the sky never brightens and the only warmth comes from within. What's certain is that these structures aren't just empty voids. They're active participants in the nebula's ecology, shielding delicate molecules from destructive radiation and possibly serving as incubators for complex chemistry. Some of the richest deposits of interstellar organic compounds, including alcohols and sugars, have been detected along their edges, where the harsh light of stars meets the protective gloom. The dark lanes aren't just hiding secrets, they might be preserving the very ingredients that make life possible. Peering into the Orion Nebula with visible light, you'd swear entire sections are empty, just dark void between the glowing gas. But switch to infrared and suddenly the scene explodes with hidden stars blazing like embers through a cosmic fog. These aren't just dim suns, they're stellar infants so young, they're still swaddled in thick blankets of dust, their visible light completely smothered. Only infrared cameras capable of seeing through the obscuring veils reveal their furious glow. What we're witnessing is stellar birth in its messiest, most violent phase. Each of these hidden stars is a protostar, a cosmic toddler still gathering mass from its surroundings. Their dusty cocoons aren't passive blankets, they're active construction zones with material spiraling inward at speeds that would cross Earth's orbit in days. The friction of this infalling gas heats the dust to hundreds of degrees, making it shine brightly in infrared while remaining utterly dark to optical telescopes. Some of these buried stars are already shaping their surroundings in dramatic ways. One particularly bright infrared source, catalogued as Orion IRC2, has carved a near-perfect spherical cavity within its dusty envelope. The star's radiation pushes outward like a plow, clearing space in the dense cloud while its gravity pulls more material inward. It's a stellar tug of war, with the protostar growing stronger by the hour. Another hidden gem, Orion SIR1, exhibits bizarre flickering, its infrared brightness swinging wildly over weeks. Astronomers suspect this could be caused by massive clumps of dust and gas collapsing into the star in fits and starts, like a fire fed by handfuls of damp kindling. The real shock comes when comparing these infrared observations with radio telescope data. Some of the most deeply embedded protostars generate powerful magnetic fields, channeling material into jets that blast outward at right angles to their spinning disks. These jets punch through the dust cocoons, creating narrow tunnels that finally allow some visible light to escape. The result, a star that's invisible head-on but reveals itself through sideways searchlights of blue-tinted radiation, a cosmic lighthouse shrouded in its own construction debris. Most humbling of all is the sheer number of these hidden stars. Surveys suggest there could be dozens still buried within the nebula's darkest folds, some so young they haven't even begun fusing hydrogen yet. They're essentially overgrown gas balls glowing from gravitational compression alone. Every new infrared scan peels back another layer of Orion's secrets, proving that what we see with our eyes is just the surface of a far richer, more dynamic stellar nursery. These obscured suns remind us that the universe's most important events often happen out of sight, wrapped in dust and mystery until the right technology pulls back the veil. One of the most startling moments in modern astronomy happened not in some distant galaxy, but right in our cosmic backyard. In January 2004, amateur astronomer J. McNeil pointed his telescope toward a familiar patch of the Orion Nebula and gasped. Where there had been only darkness days earlier, now swirled a luminous, fan-shaped cloud, glowing like a celestial light bulb switched on in the void. This was McNeil's nebula, a structure that materialized so abruptly it left professionals scrambling for explanations. The culprit, a young star previously so faint it hadn't even earned a proper name. Designation V1647 Orionis was just another unremarkable dot in Orion's stellar crowd until it wasn't. Somehow, this stellar toddler unleashed an outburst violent enough to illuminate an entire pocket of surrounding gas, transforming invisible dust into a radiant nebula practically overnight. The event wasn't just rare, it was a chance to witness stellar tantrums in real time. What makes this flare so extraordinary is its scale. Typical young star outbursts like the well-documented FU Orionis events brighten gradually over months. V1647 eruption was more like flipping a switch. In less than a week, its luminosity spiked by a factor of 25, heating nearby gas to thousands of degrees and sending shockwaves rippling outward. The nebula's structure tells the tale. Those graceful arcs aren't static, they're the aftermath of a supersonic sneeze, with gas streaming away from the star like confetti caught in a hurricane. Infrared observations peeled back even more layers of strangeness. The star sits embedded in a dense dust lane, normally a place where visible light gets smothered. Yet its eruption punched through, ionizing the surrounding hydrogen so intensely, the glow reached Earth without obstruction. That suggests this was no ordinary flare. It may have been triggered by a massive chunk of the star's own planet-forming disk collapsing inward in one dramatic cascade. Imagine a logjam breaking on a river, except here the logs are chunks of material larger than our solar system, and the river is a swirling maelstrom of gas and magnetism. The aftermath only deepened the puzzle. Within 2 years, McNeil's nebula began fading not uniformly, but in patches like a neon sign with faulty wiring. Some filaments dimmed first, while others held their glow, revealing which parts of the gas cloud were densest and slowest to cool. Then, in 28, the star flared again, weaker this time, but proving its outburst wasn't a one-time accident. It was a toddler star finding its voice, hiccuping material as it learned to regulate the furious energies of stellar infancy. This transient marvel offers more than just a light show. It's a snapshot of how stars like our Sun might have behaved in their wild youth, episodic outbursts shaping their surroundings, seeding space with heavy elements, and possibly even influencing planet formation. McNeil's nebula reminds us that the cosmos isn't some static museum exhibit. It's a living, breathing arena where change can happen breathtakingly fast if you know where to look. Hanging beneath Orion's famous belt, a celestial sword glimmers not as a straight blade, but as a gracefully curved arc of stars, gas, and cosmic violence. This is Orion's sword, a region so dense with wonders, it feels like the universe packed an entire stellar zoo into a single comma-shaped slice of sky. At first glance, the curve seems almost artistic, as if some cosmic hand drew a parenthesis in the heavens. But the truth is far more dynamic. This elegant bend is the result of gravitational tugs of war between massive stars, each one warping space-time like invisible fingers molding clay. The sword's curvature tells a story of sibling rivalry. At its heart, the Trapezium Cluster's heavyweight stars exert such colossal pull, they've twisted the surrounding gas into a bow shape like a ribbon caught in a breeze. Meanwhile, newborn stars buried deeper in the nebula push back, their own gravity creating counter-curves and ripples. The result is a delicate balance, an arc that appears frozen in time but is actually a snapshot of an endless struggle between creation and destruction. But the real marvels hide along this curve. Nestled within its sweep is the iconic Orion Nebula, glowing with the light of 1,000 newborn suns. Just to its south lies the fainter but equally intriguing M43, a bubble of ionized hydrogen being sculpted by a single massive star's radiation. And then there's the Running Man Nebula, its shadowy silhouette forever mid-stride as it flees the trapezium's blistering glare. Each of these phenomena is shaped by the sword's overarching curve, their positions and forms dictated by the same gravitational choreography. Infrared observations reveal even stranger details. The curve isn't uniform, it's kinked in places where rogue planets or brown dwarfs tug unseen, their mass creating tiny gravitational dimples. In one spot, astronomers found a chain of protostars aligned like beads on a string, their formation likely triggered by a shockwave that raced along the sword's curvature millennia ago. Elsewhere, dark lanes intersect the arc at sharp angles, marking where magnetic field lines have stitched the gas into unnatural-looking geometries. What's truly breathtaking is how this curve serves as a cosmic incubator. The gravitational forces that bend the sword also compress gas along its inner edge, creating perfect pockets for new stars to ignite. Some of these stellar infants are already visible tiny pinpricks of blue-white light tucked into the arc's embrace. Others remain hidden, their presence betrayed only by the way they distort the curve's smoothness like weights on a suspended rope. The sword's shape isn't permanent. Over millennia, the trapezium stars will drift apart, their weakening grip allowing the curve to relax. New supernova might blast through, straightening segments like a cosmic iron. But for now, Orion's sword remains one of the sky's most exquisite examples of how gravity doesn't just pull, it sculpts, arranges, and occasionally writes poetry in the stars. Nestled within the Orion Nebula's fiery embrace, Hubble's sharp eye has captured some of the universe's most delicate structures, protoplanetary disks or propellids. These glowing rings of dust and gas are cosmic cradles where planets slowly coalesce around newborn stars. But here's the twist: many of these disks aren't just peacefully forming worlds, they're locked in a desperate race against time, their material evaporating under the relentless glare of nearby stellar giants. One of the most striking examples is a propellid catalogued as 182-335. From a distance, it looks like a celestial umbrella, a dark, tadpole-shaped disk with a long, glowing tail streaming behind it. The umbrella part is the disk itself, dense enough to shield its inner regions from the Trapezium Cluster's brutal ultraviolet radiation, but the tail, that's gas being stripped away at over 60,000 miles per hour, ionized until it fluoresces like a neon sign. The star at this disk center is essentially trying to build planets while a cosmic hurricane tries to blow its construction materials into deep space. Not all propellids face the same fate, though. Their survival depends on location. Disks nestled in quieter corners of the nebula, farther from massive stars, retain their material longer, some even showing concentric gaps where young planets may already be carving orbits. But those unfortunate enough to orbit near the trapezium's heavyweights, they're on borrowed time. Hubble has caught several in mid-disintegration, their outer layers boiling off into space, leaving behind eerie, comet-like trails. One particularly haunting example, propellid 224-540, looks like it's being unwound like a spool of thread, its gases spiraling outward in a luminous helix. What's fascinating is how these evaporating disks defy expectations. Conventional wisdom said such harsh environments should prevent planet formation entirely. Yet observations reveal something remarkable. Some disks are losing their outer layers while their inner regions remain intact, shielded by their own density. It's like a tree shedding leaves in a storm while its trunk stays rooted. This means planets could still form close to the star, even as the disk's outer edges fray into nothingness. The implications are staggering. If worlds can take shape in these extreme conditions, it suggests planet formation is far more resilient than we imagined. Maybe our own solar system endured similar trials in its youth, battered by nearby supernova or radiation from passing giants, yet still managing to forge the worlds we know today. Every evaporating propellid in Orion isn't just a casualty of cosmic violence. It's a testament to the universe's stubborn creativity, forging order from chaos against all odds. Among the Orion Nebula's countless wonders, few sights rival the elegance of HH34, a pair of perfectly mirrored jets stretching 2.5 light-years across space, their delicate symmetry frozen in a celestial bow tie. This isn't some abstract art installation, it's the aftermath of a violent stellar tantrum, where a young star hurls superheated gas from its poles at nearly 500,000 miles per hour. What makes HH34 mesmerizing isn't just its speed or scale, it's the precision of its geometry, as if nature itself took a protractor to the cosmos. At the heart of this spectacle lies a star barely old enough to fuse hydrogen, its violent adolescence on full display. As the star greedily feeds on surrounding gas, some material escapes along magnetic field lines, funneled into twin jets that blast outward like cosmic fire hoses. Normally, such outflows wobble or kink as they navigate the nebula's turbulent currents. But HH34 defies expectations. Its jets curve in flawless arcs, their mirrored trajectories tracing identical parabolas on either side of the star. It's a level of symmetry rarely seen in the universe's chaos, suggesting an eerie stability in the star's magnetic environment. The secret lies in the star's spin. Unlike most protostars, which tumble unpredictably as they form, this one rotates with metronomic consistency. Its axis stays locked in place like a gyroscope, allowing the jets to maintain their pristine curves even as they plow through clouds of resistance. Each jet terminates in a glowing shock front, the knots of the bow tie, where the supersonic flow slams into slower-moving nebula gas. These collision zones fluoresce in vivid reds and blues, with hydrogen atoms glowing like neon signs as they're excited by the impact. What's truly staggering is the timescale. While the bow tie appears static in our snapshots, it's actually a dynamic structure evolving in real time. Hubble images taken years apart reveal subtle changes, new knots forming downstream as the star experiences fresh outbursts, while older ones dissipate like smoke rings fading in the wind. By measuring these shifts, astronomers have calculated the jet's velocity with startling precision, confirming they're among the fastest stellar outflows ever recorded. But the most tantalizing detail hides in the jet's chemistry. Spectroscopic analysis reveals they're laced with heavy elements: silicon, iron, even traces of nickel, atoms typically forged deep within stars, not ejected by infants like this one. The likely explanation: the jets are scavengers, plowing through and vaporizing nearby dust grains rich in these materials. It's a reminder that even the universe's most beautiful phenomena are born from violence, a stellar child throwing a fit, while inadvertently seeding future worlds with the building blocks of planets. HH-34's symmetry offers more than just aesthetic appeal. It's a rare window into the hidden order underlying stellar formation. For all the chaos of the Orion Nebula, here we see a system operating with near-clockwork precision, its elegance preserved against all odds. In a region where randomness reigns, this bow tie stands as a testament to the delicate balance between turbulence and control, a fleeting masterpiece written in plasma and starlight. Beneath the dazzling spectacle of the Orion Nebula lies something far more massive and nearly invisible. The Orion molecular cloud complex doesn't glow with vibrant colors or sculpt elegant pillars. Instead, it looms in radio silence, a monstrous reservoir of cold hydrogen and dust so dense it blocks visible light entirely. This is the nebula's shadowy backbone, a cosmic warehouse of raw materials stretching dozens of light years, containing enough gas to forge thousands of new stars. What makes this cloud extraordinary isn't just its size, it's how it hides in plain sight. Optical telescopes see only the nebula's radiant surface, like spotting foam on an ocean wave, while missing the dark water beneath. To uncover the cloud's true scale, astronomers must switch to radio frequencies, where molecules like carbon monoxide vibrate with telltale signatures. These radio whispers reveal a landscape of staggering complexity: filamentary tendrils weaving through space like cosmic spider silk, each thread dense enough to birth entire stellar clusters. Some regions are so packed, a volume no larger than our solar system could hold enough material to outweigh the sun 1,000 times over. The cloud structure defies simple explanation. Turbulence from ancient supernova has carved it into frothy bubbles, while gravity pulls it into knotty protostellar cores. Magnetic fields crisscross the chaos, channeling material into flows that resemble earthly rivers. Except these rivers are light years long and flow at 500,000 miles per hour. Infrared scans expose even stranger features: vast caverns hollowed out by stellar winds, their walls glittering with frozen organic molecules. In some pockets, temperatures plunge near absolute zero, allowing hydrogen to pair up into fragile molecular bonds rarely seen elsewhere in the galaxy. But the real magic happens where the cloud interacts with the nebula. Ultraviolet radiation from the trapezium stars is eating into the molecular material like acid, triggering waves of star formation at the boundary. This slow-motion collision creates a feedback loop: new stars ignite, eroding the cloud further, which compresses remaining gas until more stars ignite. It's a self-perpetuating stellar assembly line, with the molecular cloud feeding raw materials into the nebula's fiery workshops. What's most humbling is realizing this process mirrors our own solar system's origins. Radioisotope dating of meteorites suggests our sun was born in a neighborhood much like Orion, perhaps even within a similar molecular behemoth. The same organic molecules detected in this cloud water, methanol, even simple sugars, may have once drifted into the collapsing ball of gas that became our sun and planets. The Orion molecular cloud isn't just a distant curiosity, it's a time machine, showing us the exact conditions that set the stage for Earth's creation billions of years ago. Yet for all its grandeur, the cloud is ephemeral. Within a few million years, the combined onslaught of star formation and radiation will blast it apart, its materials either locked into new stars or scattered across interstellar space. We're witnessing a fleeting moment in its life cycle, a cosmic giant quietly dissolving as it fuels the next generation of starlight. The nebula's brilliance may steal the show, but the molecular cloud is the unsung architect, shaping Orion's beauty from the shadows. At the core of the Orion Nebula's brilliance lies a gravitational maelstrom, the Theta Orionis system, a quartet of stars locked in a dance so chaotic, it reshapes the surrounding nebula with every orbit. These aren't just any stars, each member is a colossal, blue-white behemoth radiating energy so intense, their combined light outshines thousands of suns. The system's primary star, Theta 1 Orionis c, stands as one of the most luminous stars in our galactic neighborhood, blasting its siblings with enough ultraviolet radiation to strip atmospheres from hypothetical planets light years away. What makes this four-star tango so extraordinary is the sheer instability of their arrangement. Unlike orderly planetary orbits, Theta Orionis stars whirl around one another in wildly eccentric paths, their closest approaches unleashing gravitational shockwaves. Infrared observations reveal their movements in startling detail. One pair orbits so tightly they could fit between the Sun and Mercury, while another duo swings wide enough to occasionally plow through the nebula's densest gas clouds. Every close encounter sends ripples through the surrounding material, compressing gas into new star-forming zones or flinging pre-existing protoplanetary disks into deep space like cosmic shrapnel. The system's most dramatic impacts are written in the nebula's structure. Vast cavities, some spanning multiple light years, have been hollowed out by Theta 1 Orionis sees stellar winds, hurricanes of charged particles moving fast enough to circle Earth twice in a second. Nearby, eerie tendrils of gas stretch toward the stars like fingers grasping for balance, their shapes warped by conflicting gravitational tides. One particularly striking feature, nicknamed the dance floor, shows concentric rings of shocked gas where the stars' overlapping outflows collide, creating interstellar sound waves visible in radio telescopes. Yet the real spectacle unfolds on a human timescale. Over mere decades, astronomers have documented measurable shifts in the star's positions. Theta 1 Orionis b, for instance, has veered unexpectedly closer to its neighbors, its path suggesting an unseen fifth member might be tugging from the shadows. Meanwhile, Theta 1 Orionis' erratic brightness fluctuations hint at massive sunspots or violent magnetic reconnection events, turning the star into a cosmic strobe light. The implications of this stellar chaos extend far beyond Orion. Theta Orionis serves as a laboratory for understanding how massive star clusters evolve, revealing how gravitational interactions can disperse or concentrate star-forming material on galactic scales. Every flare, every orbital shudder leaves an indelible mark on the nebula, proof that even in the vastness of space, no star is an island. The system's turmoil is a reminder that creation in the cosmos is rarely gentle. It's sculpted by collision, carved by radiation, and ultimately rewritten by the ceaseless motion of giants dancing in the dark. Tucked just north of the Orion Nebula's dazzling core, a smaller but no less fascinating structure glows with its own quiet intensity, M43. Often overshadowed by its famous neighbor, this compact nebula is more than just a side note in Orion's cosmic drama. It's a self-contained stellar nursery, a pocket of ionized hydrogen where young stars sculpt their surroundings with winds and radiation. At first glance, M43 appears as a delicate teardrop of light, but peer closer, and you'll uncover a microcosm of the same explosive processes that define its larger sibling. The nebula owes its glow to a single massive star, HD 37036, a blue giant so luminous it ionizes the surrounding gas all by itself. Unlike the Trapezium Cluster's chaotic energy, M43's lighting is a one-star show, creating a more orderly but no less dynamic environment. The star's ultraviolet radiation carves a near-perfect spherical cavity in the gas, its edges fluorescing in soft pinks and blues. But there's tension beneath the serenity. Stellar winds from HD 37036 slam into denser pockets of the nebula, forming rippling shock fronts that resemble frozen waves in a cosmic sea. What makes M43 truly special is its scale. Here, astronomers can study stellar feedback mechanisms in a simplified, almost laboratory-like setting. Without the interference of multiple massive stars, the cause and effect relationships are clearer. For example, infrared observations reveal tendrils of dust being slowly evaporated by the central star's radiation, a process that would be lost in the Orion Nebula's cacophony. Meanwhile, radio telescopes have detected subtle changes in the nebula's shape over just a few decades, evidence of HD 37036's growing influence on its cradle. But the real drama lies in the shadows. Dark streaks crisscross M43's glow, not just as passive dust lanes but as active star-forming regions. One particularly dense filament, catalogued as M43S1, harbors half a dozen protostars in various stages of formation. Their infrared signatures show some are still swaddled in thick dust cocoons, while others have begun peeking out, their light punching holes in the surrounding gas like fingers through wet paper. This simultaneous erosion and creation makes M43 a microcosm of stellar life cycles, a place where destruction and birth share the same stage. Perhaps most intriguing is the nebula's relationship with its famous neighbor. M43 isn't an isolated bubble, it's connected to the Orion Nebula by faint bridges of gas, remnants of the larger molecular cloud from which both formed. Spectroscopy reveals these filaments are highways of material, with atoms being stripped from M43's edges and dragged toward the trapezium's gravitational pull. It's a slow-motion merger, a dance of nebulae that will eventually see M43 absorbed into Orion's grandeur. For now, this miniature marvel stands as a reminder that even space's quieter corners harbor extraordinary stories. While the Orion Nebula shouts its brilliance, M43 whispers, but its whispers carry secrets just as profound. In its delicate balance of forces, we see the universe's creativity distilled to its essence: one star, one nebula, and the endless interplay of light and darkness. Hidden within Orion's swirling gases, a young star unleashes chaos in hypnotic slow motion at H505. A pair of plasma jets so twisted, they resemble cosmic corkscrews frozen mid-spiral. Unlike the elegant symmetry of HH34 or the boomerang jets we've seen earlier, these outflows contort into wild, asymmetrical loops, each bend a violent record of unseen forces warping their path. At their source, a stellar infant no older than 50,000 years spews superheated gas at 300,000 miles per hour. But by the time these jets reach the nebula's outskirts, they've been wrung into shapes that defy textbook astrophysics. The culprit behind this stellar origami, a perfect storm of interference. First, the star's own magnetic field, tangled by its rapid spin, whips the jets into initial curves like water from a spinning garden hose. Then hurricane force winds from nearby massive stars buffet the flows sideways, their pressure sculpting the plasma into tighter kinks. But the final twist comes from something invisible: dense pockets of interstellar gas lurking in the jet's path. As the supersonic streams plow into these unseen obstacles, they ricochet, sending shockwaves rippling back toward the star itself. The result: a cascade of collisions that leaves the jets crumpled like discarded ribbon. Hubble's time-lapse observations reveal the drama unfolding in real time. Over just 15 years, one segment of the southern jet has bent an additional 12 degrees, equivalent to a highway curve tightening by a full lane's width annually. This isn't just gradual erosion, it's proof of the nebula's turbulent undercurrents reshaping stellar outflows on human timescales. Spectroscopy adds another layer of strangeness. The jet's northern arm glows significantly brighter in oxygen emissions, suggesting it's plowing through a chemically distinct region of the nebula, while the southern arm's sulfur-rich spectrum hints it's burrowing into denser, dustier terrain. What's most unsettling is how these contortions affect planet formation. Normally, bipolar jets clear space around young stars, creating tidy orbits for developing worlds. But HH-505's warped outflows scatter material unpredictably. Some gas gets flung into deep space, while other fragments rain back onto the star's protoplanetary disk like cosmic shrapnel. Astronomers have even spotted strange, arrowhead-shaped shocks along the jet's edges, evidence of material being sandblasted sideways by crosswinds from the trapezium stars. It's a stellar nursery where the crib itself is under siege, yet within this chaos lies a revelation. The jet's very distortions act as a diagnostic tool, revealing otherwise invisible forces. Each kink maps the strength of passing stellar winds. Every brightness fluctuation traces hidden gas densities. Like seaweed swaying in ocean currents, HH-505's tortured geometry paints a portrait of the nebula's secret tides, proof that sometimes the universe's most violent processes create unexpectedly delicate tracers. These twisted jets aren't just celestial oddities, they're living textbooks on how young stars negotiate their tumultuous birth environments, one wild, whirling loop at a time. Encircling the Orion Nebula like a celestial soap bubble, the ethereal structure known as Orion's veil stretches over 24 light-years across, a fragile-looking yet astonishingly resilient cocoon of gas and magnetic fields. This shimmering boundary isn't just a visual spectacle. It's the front line of an epic battle between the trapezium star's furious winds and the relentless pressure of interstellar space. Picture blowing on a dandelion puff, except instead of seeds scattering, you're watching a trillion-degree plasma front carve its way through the cosmos, sculpting a membrane so thin, in places it's just a few atoms thick. What gives the veil its ghostly glow is a phenomenon called fluorescence. As the trapezium's ultraviolet radiation slams into the bubble's inner wall, it strips electrons from hydrogen atoms, turning the gas into a luminous plasma. But here's where it gets bizarre. Instead of bursting like an overinflated balloon, the veil maintains its structure through an invisible web of magnetic fields. These force lines act like cosmic rebar, reinforcing the gas against disruption while allowing it to flex and ripple in response to external pressures. Some sections billow outward where stellar winds push hardest, while others sag inward where the nebula's denser regions resist expansion, creating an ever-shifting topography visible in radio telescope maps. The veil's transparency reveals even stranger details. Hubble's ultraviolet sensors have spotted thousands of finger-like protrusions dubbed ionization fronts, where radiation leaks through weaker spots in the bubble, evaporating nearby molecular clouds like sunlight burning off morning fog. Meanwhile, infrared observations show the veil's far side curdling into dense knots as it collides with cooler interstellar material, forming a frothy boundary layer where temperatures plummet from millions of degrees to near absolute zero within a single light year. This temperature gradient creates surreal effects. Gas on the hot inner surface emits X-rays, while just beyond the wall, molecules like carbon monoxide freeze into icy coatings on dust grains. But the veil's most astonishing feature is its motion. By comparing decades of observations, astronomers have clocked the bubble expanding at nearly 15,000 miles per hour, fast enough to cross Earth's diameter in under 30 minutes. Yet instead of slowing as expected, the expansion seems to be accelerating in some sectors, suggesting hidden energy sources are at work. One theory points to repeated supernova shocks from massive stars that died long before the trapezium formed, their explosive echoes still pumping energy into the system like ghostly bellows. This fragile-looking structure is anything but delicate. It's a dynamic filter regulating how the nebula interacts with the wider galaxy. While the veil shields inner regions from harsh cosmic rays, it also funnels processed stellar material, oxygen, silicon, even gold atoms forged in stellar cores outward into interstellar space. Every element heavier than helium in your body likely passed through such a bubble billions of years ago. The veil isn't just a boundary, it's a cosmic recycler, proof that even the universe's most transient structures can shape the chemistry of future stars, planets, and perhaps life itself. In the grand theater of the Orion Nebula, shadows aren't just absences of light, they're cosmic spotlights revealing secrets we'd otherwise never see. One of the most dramatic examples is a protoplanetary disk so perfectly aligned, it casts a shadow stretching an astonishing 3 light-years across the nebula's glowing canvas. This isn't just a dark smudge, it's a celestial sundial on an interstellar scale, where the interplay of light and darkness exposes the hidden architecture of a fledgling solar system. This silhouette disk owes its stark profile to a rare geometric alignment, a young star, its surrounding disk, and the Trapezium Cluster's brightest members all lining up with near-perfect precision from our vantage point. The star itself is invisible, buried within the disk's dense inner regions, but its influence is unmistakable. The disk's thick central hub blocks the trapezium's intense ultraviolet light completely, creating a wedge-shaped shadow so crisp its edges could have been drawn with a ruler. Meanwhile, the disk's thinner outer layers filter the starlight like frosted glass, producing a gradient of twilight that fades into the nebula's glow. The result is a natural cosmic projector backlighting the disk's structure with impossible clarity. What makes this shadow so invaluable to astronomers isn't just its size, it's the details etched within. Fine irregularities along the shadow's edges reveal spiral density waves in the disk, ripples likely caused by newborn planets stirring the material like spoons in thick syrup. Subtle brightness variations suggest gaps where unseen worlds have swept their orbits clean, while faint, finger-like protrusions hint at magnetic fields funneling material onto the star. Normally, these features would require painstaking indirect measurements, but here they're projected in plain sight across light years of nebula, a natural X-ray of planet formation. The shadow's edges also serve as a laboratory for studying interstellar optics. As the trapezium's light grazes the disk's upper layers, it scatters off dust grains, creating a phenomenon called forward scattering. This produces an eerie, blue-tinged halo around the shadow's border, the cosmic equivalent of sunlight diffusing through Earth's atmosphere at sunset. By analyzing this glow, scientists have calculated the exact size distribution of dust particles in the disk's upper atmosphere, revealing them to be smaller and more uniform than expected. Some theorize intense stellar radiation has sandblasted away larger grains, leaving behind only the finest dust mist to scatter light. Yet the most startling realization is how fleeting this alignment must be. Protoplanetary disks typically tilt and precess over time, their orientations shifting as neighboring stars' gravity tugs on them. Within a few thousand years, a blink in cosmic terms, this precise lineup will dissolve, the shadow warping and fading as the disk reorients. We're witnessing a celestial photo op so brief, it makes a total solar eclipse seem like an eternal monument. For perspective, consider this. The shadow we see today began its journey when early humans were first domesticating wolves. The light now outlining its contours left the trapezium stars around the same time the pyramids were rising in Egypt. And by the time the shadow's final photons reach us, human civilization may have transformed beyond recognition. The silhouette disk is more than a shadow. It's a time capsule, a cosmic alignment so precise and transient, we're privileged to witness it at all. In its darkness, we find illumination, a rare window into the delicate mechanics of how worlds are born. While our eyes marvel at the Orion Nebula's vibrant colors, there's an invisible storm raging beneath the surface, a tempest of radio waves so intense they drown out nearly every other stellar nursery in our galactic neighborhood. These aren't gentle whispers of energy, they're full-throated screams from some of the universe's most violent processes, detectable only when we tune our instruments to wavelengths far beyond what human eyes can perceive. At the heart of this radio fury lies a phenomenon called free emission, a technical term for what happens when electrons, torn from atoms by brutal ultraviolet radiation, crash into other particles without reattaching. Picture a cosmic pinball machine where the balls are charged particles and the bumpers are ionized gas clouds. Each collision emits a burst of radio energy, and in Orion, these collisions happen trillions of times per second across light years of space. The result, a roar of radiation so powerful, early radio astronomers initially mistook it for instrumental error. But the real shock comes when we map these radio emissions against visible images. Towering pillars that appear serene in Hubble photos crackle with violent energy in radio maps, their bases lit up like lightning rods in a thunderstorm. Meanwhile, seemingly placid regions between stars turn out to be crisscrossed by filamentary currents, invisible highways where magnetic fields channel particles at near light speeds. One particularly intense source, dubbed Orion Radio Hotspot 1, flickers unpredictably, sometimes flaring to 10 times its usual brightness in under an hour. The culprit, a runaway protostar still shrouded in dust, may be periodically dumping massive clumps of material onto its surface, triggering thermonuclear tantrums visible only in radio static. What's truly unsettling is how these radio waves reveal forces that defy our understanding of stellar nurseries. In certain frequencies, the nebula emits polarized radio signals, a sign that magnetic fields thousands of times stronger than Earth's are twisting the fabric of space itself. These fields don't just organize the chaos, they accelerate particles to energies that dwarf anything our most powerful colliders can produce. Some electrons spiral along these magnetic lines so fast, they emit not just radio waves but X-rays, effectively turning the nebula into a natural particle accelerator the size of our solar system. The implications ripple far beyond Orion. Similar radio signatures have been detected in distant galaxies, suggesting the processes churning here might be universal, a fundamental language of how stars are born in the cosmic dark. Every crackle and pop from Orion's radio cacophony is more than just noise. It's a fingerprint of creation's raw power, etched in wavelengths we're only beginning to decipher. The nebula's beauty may draw our gaze, but its hidden radio fury holds the keys to understanding how the universe's most brilliant lights emerge from chaos. Near the Orion Nebula's bustling stellar nursery, a newborn star unleashes a spectacle of raw cosmic power, the Herbig-Haro object HH24. This isn't just another jet-spewing protostar, it's a pristine, double-sided fury, ejecting twin beams of superheated gas in perfectly opposing directions like a celestial spinning top gone rogue. Each jet stretches over half a light-year long, glowing with the fierce blue-white intensity of ionized hydrogen atoms slammed together at nearly 300,000 miles per hour. The star at the heart of this chaos is barely a cosmic toddler, less than 50,000 years old, yet it's already mastering one of the universe's most violent balancing acts. As gas from its surrounding disk spirals inward, the star's magnetic field channels some material away from its poles, creating these opposing jets. But HH24's symmetry is deceptive. While the jets appear mirrored from our vantage point, closer inspection reveals subtle betrayals of the chaos beneath. The northern jet curves slightly, warped by an encounter with denser nebular gas, while the southern jet sports a string of glowing knots, each one a fossilized record of past stellar outbursts, like breadcrumbs marking moments when the star devoured particularly massive clumps of material. Hubble's razor-sharp vision exposes even stranger details. The jets aren't smooth flows but braided rivers of plasma, their twists revealing where magnetic field lines have become tangled like spaghetti in the star's turbulent interior. Near the base, shock diamonds regularly spaced bright spots resembling a cosmic barcode form where faster-moving material rams into slower ejecta from earlier bursts. These structures pulse visibly over just a few years, proving that protostars don't grow steadily but in violent fits and starts. What makes HH24 truly exceptional is its role as a cosmic Rosetta Stone. By comparing its well-defined jets to messier examples elsewhere in Orion, astronomers have decoded how stellar outflows evolve over time. Younger jets like these are narrow and collimated, focused by their star's strong magnetic fields. Older jets, battered by passing shockwaves and radiation, fray into sprawling, disjointed tendrils. HH24 captures the brief, brilliant moment when a star's outflows are at their most organized before the nebula's chaos inevitably tears them apart. Spectroscopy adds another layer of revelation. The southern jet glows slightly redder than its northern counterpart, not from Doppler shifting but from chemical enrichment. Apparently, this side plowed through a dust cloud rich in iron and silicon, vaporizing the grains and painting its outflow with elemental graffiti. Meanwhile, the base of both jets shows traces of deuterium-heavy hydrogen normally destroyed by stellar heat. Its survival suggests material is being flung out faster than it can cook, a reminder that protostars are as messy as they are powerful. This bipolar fury isn't just for show, it's a vital release valve. Without these jets carrying away excess energy and angular momentum, the spinning star would tear itself apart. Every atom ejected stabilizes the system, allowing the star to keep growing while its eventual planets form in the peace of the equatorial disk. HH24's lethal beauty is ultimately constructive, a stellar birth cry that ensures quieter tomorrows. In the heart of Orion's chaos, a silent revolution unfolds, one where dust, the most unassuming ingredient of the cosmos, becomes both casualty and catalyst in an endless cycle of destruction and rebirth. These microscopic grains, smaller than a wavelength of light, might seem insignificant against the nebula's grand vistas, but they hold the keys to stellar alchemy. Each speck is a time capsule forged in the explosive depths of ancient stars and now drifting through Orion's turbulent currents, awaiting its next cosmic purpose. The journey begins violently. Near the Trapezium Cluster's blistering stars, ultraviolet radiation bombards dust grains like sandblasters, stripping away atoms layer by layer. Silicate particles, essentially cosmic sand, sublimate directly from solid to gas, while carbon-based grains fracture into delicate chains of molecules. In some regions, the onslaught is so intense that dust is annihilated entirely, reduced to its elemental components in seconds. Yet this demolition isn't the end, it's the first step in a transformation. The same radiation that destroys dust also ionizes the liberated atoms, energizing them to collide and form new compounds. Carbon joins with hydrogen to create hydrocarbons. Silicon bonds with oxygen to birth fresh silicate precursors. It's a stellar recycling plant where the ashes of old grains become the raw materials for new ones. But the real magic happens in the shadows, beyond the trapezium's fury, in the cooler recesses of the nebula. These vaporized elements cling to surviving dust grains, building up icy mantles of water, methane, and ammonia. Infrared telescopes spot these coated grains by their telltale absorption features like cosmic fingerprints in the spectrum. Within these icy layers, chemistry thrives. Ultraviolet light, though weaker here, still penetrates enough to trigger reactions, transforming simple ices into complex organics. Some grains even harbor probiotic molecules like formaldehyde and methanol, the molecular precursors to life's building blocks. The cycle accelerates where opposing forces meet. Along shock fronts carved by stellar winds or supernova, dust grains collide at supersonic speeds, shattering into nanoscale fragments. These nanoparticles behave unlike their bulkier predecessors. Their tiny size gives them bizarre quantum properties, allowing them to absorb and re-radiate energy with freakish efficiency. Some become cosmic matchsticks, igniting chain reactions that convert interstellar formaldehyde into sugars. Others act as catalysts, accelerating the formation of molecular hydrogen on their surfaces, the very fuel that powers star formation. What's astonishing is how these processes scale. Every year, the Orion Nebula destroys and reforms an estimated Earth mass worth of dust. Over millennia, this constant churn seeds future generations of stars with chemically enriched materials. The same iron atoms that once anchored a dust grain near a dying star might later find themselves inside a rocky planet orbiting a newborn sun. This isn't just recycling, it's cosmic inheritance, a testament to the nebula's role as both cradle and crucible. The implications stretch far beyond Orion. Similar dust cycles likely operated in the cloud that birthed our solar system, meaning the silicon in your phone and the carbon in your DNA might have once ridden such grains through an ancient stellar nursery. The dust we watch being obliterated and reborn today isn't just interstellar debris, it's the raw material of futures we can't yet imagine. A reminder that creation in the universe is never truly from scratch, but always from stardust reshaped. The Orion Nebula isn't just a cosmic masterpiece, it's a ticking time bomb. The same stars that light up its gaseous canvas with breathtaking brilliance are destined to self-destruct in explosions so violent, they'll reshape the nebula's future and seed the galaxy with the raw materials for new worlds. At the heart of this impending chaos are the Trapezium's heavyweight stars, each one a volatile beast with lifespans measured in millions, not billions, of years. Their eventual deaths won't be quiet fade-outs, they'll be cataclysmic supernova detonating with enough force to outshine entire galaxies for weeks. Consider Theta 1 Orionis C, the nebula's brightest star. This blue giant burns through its nuclear fuel at a reckless pace, its core fusing helium into heavier elements like a runaway furnace. In just a few million years, a blink in cosmic terms, it will exhaust its fuel, collapsing under its own gravity before rebounding in a supernova explosion powerful enough to vaporize nearby protoplanetary disks and send shockwaves rippling through the nebula's delicate structures. The aftermath, a rapidly expanding bubble of hot gas, laden with freshly forged elements like gold, platinum, and uranium metals that will one day be incorporated into future planets or even life. But the destruction won't end there. Supernova trigger chain reactions. When one trapezium star explodes, the blast wave will compress surrounding gas, igniting new stars while simultaneously eroding others. Imagine a domino effect of stellar fireworks, where each explosion sets the stage for the next. Some models predict the entire Orion molecular cloud complex, the nebula's hidden backbone, could be shredded apart within 10 million years, its materials scattered across interstellar space. The iconic pillars and tendrils we admire today, reduced to wisps, their dust and gas recycled into fresh stellar nurseries light years away. Yet this apocalypse carries a creative twist. The same explosions that obliterate Orion's current form will sow the seeds for its legacy. Supernova are the universe's ultimate alchemists, transforming simple elements into complex atoms. Carbon for future organic molecules, iron for planetary cores, oxygen for atmospheres. All these vital ingredients will be blasted into the void, eventually coalescing into new stars, planets, and perhaps even life-bearing worlds. Our own solar system likely formed from similar debris, the remnants of long-dead stars that flared into oblivion billions of years ago. the nebula's fate isn't just a distant spectacle, it's a preview of our cosmic neighborhood's future. The Pleiades, that glittering star cluster visible in winter skies, was once an Orion-like nebula before its massive stars exploded and blew away their cradle. Orion will follow suit, its brilliance fading as its stellar architects meet their fiery ends. But in their death throes, these stars will gift the galaxy something far more enduring, the promise of new beginnings written in stardust and supernova light. What makes this inevitable transformation so profound is its scale. The explosions will be visible from Earth, perhaps outshining the Moon for generations. Future astronomers, human or otherwise, might witness Orion's gradual dissolution, tracking the expanding shells of gas as they merge with the interstellar medium. And somewhere, in some distant corner of the galaxy, the nebula's recycled materials will ignite anew, lighting up another pocket of darkness with the same creative fury that once defined Orion. The cycle isn't just inevitable, it's essential. Without these stellar deaths, the universe would lack the diversity of elements needed to build rocky planets, oceans, or living cells. Orion's brilliance is fleeting, but its impact echoes across cosmic time. The nebula's looming destruction isn't an end, it's a metamorphosis, a fiery rebirth that ensures its story continues in the chemistry of unborn stars and the untold worlds that will one day orbit them. The same violence that unravels Orion's beauty will forge the next chapter of our galaxy's evolution, proving that even in the cold vastness of space, nothing truly dies, it simply changes form. From the cosmic fireworks of Herbig-Harrowed jets to the ghostly whispers of evaporating protoplanetary disks, the Orion Nebula has revealed itself as far more than a pretty cosmic cloud. It's a universe in miniature, where every corner holds phenomena that push the boundaries of what we thought possible. We've witnessed stellar toddlers throwing tantrums with jets of superheated gas, rogue planets drifting untethered through the darkness, and magnetic fields strong enough to twist space itself into knots. We've seen shadows stretch light years across the void, silent explosions sculpt gas into delicate loops, and dust grains transform from cosmic rubble into the building blocks of worlds. Each of these 30 wonders, from the Trapezium Cluster's gravitational dance to the eerie symmetry of the cosmic bat, from the supersonic Orion bullets to the delicate chemistry of the Orion Bar, paints a portrait of creation in its rawest form. This nebula isn't just a birthplace for stars, it's a laboratory where physics flexes its most extreme muscles, where the universe tests its wildest ideas. The same violent processes that tear gas clouds apart also weave them into new structures, proving that destruction and creation are two sides of the same cosmic coin. But the greatest marvel might be how much we still don't understand. Why do some protostars eject perfectly symmetrical jets while others spiral into chaos? What lurks in those dark lanes where even infrared light struggles to penetrate? And how many more surprises wait hidden in the nebula's shimmering folds? Every answer Orion offers seems to spawn 10 new questions, and that's what makes it endlessly fascinating. Now it's your turn. Which of these phenomena left you in awe? Was it the Horsehead's stubborn silhouette defying erosion against all odds? The boomerang jet's impossible curves bent by forces we can barely measure? Or maybe McNeil's nebula materializing overnight like a cosmic light switch flicked on? Drop your favorites in the comments, and if there's a space mystery you'd love us to explore next, whether it's the screaming void of a black hole or the frozen oceans of Europa, let us know. The universe is brimming with wonders, and together we'll keep unraveling them one star at a time. Until then, keep looking up. The cosmos has so much more